The following is an explanation of example 512 out of the textbook on page 204. We are told that calcium oxide, or quicklime, is produced by the thermal decomposition of calcium carbonate. We're asked to calculate the volume of carbon dioxide at STP produced from the decomposition of calcium carbonate. The reaction we're given is that calcium carbonate, which is a solid, decomposes into calcium oxide, which is also a solid, and carbon dioxide, which is a gas. The gas law as part of this question comes with that carbon dioxide. However, I'm not quite there yet. I'm starting with 152 grams of calcium carbonate. As with any time I'm given grams, I want to almost immediately convert it straight into moles. And I do that by dividing by the molar mass, which is 100.09 grams per mole. I do this, I get a value of about 1.52 moles of calcium carbonate. Now I have to make sure that my reaction is balanced. However, I'm given the reaction in the textbook, and if I just do a quick check, 1 calcium, 2 calcium, 1 carbon, another carbon, 3 oxygens, 1, 2, 3 oxygens, we're good. So if I have 1.52 moles of calcium carbonate, I just do a simple mole-to-mole conversion with calcium carbonate on the bottom, and the thing I'm interested in, that carbon dioxide on the top, it's a 1-to-1 ratio, I get 1.52 moles. Now, I'm given STP as my conditions. If I have moles and I have STP, I can do a very, very quick conversion into volume. And the conversion factor I'm going to use is that 1.00 liters equals 1.00 moles equals 22.4 liters. I could go ahead and use that standard temperature being 273 Kelvin, that standard pressure being 1 atmosphere, and do a PV equals nRT. However, this is much, much quicker because I've got a little over 1.5 moles. So I'm going to have a little over 1.5 times that 22.4. 1.52 moles times the conversion factor with 22.4 liters on the top and 1 mole on the bottom. And I get 34.1 liters as my answer. Again, I could go through and do the PV equals nRT, but I would rather save my work for when I'm not given STP as my conditions. STP is quite frequently used when we have these kinds of gas stoichiometry questions, as it will help reduce the sheer amount of work that we have to do. Again, this is example 5.12 out of the textbook located on page 204.